Welcome, ladies and gentlemen, to our next presentation here on stage. The EPLM AG is a smart expert partner of Siemens Industry Software and a specialist for the entire PLM process. They identify the breakdowns and gaps in the PLM process, and together with the customer, the EPLM develops a PLM strategy with a customized action plan that leads to controllable results. Their portfolio covers the consulting along the PLM process, the distribution of the Siemens Industry Software portfolio with the focus on the AM value chain from begin to end, and the implementation of the software, and also a corresponding support service for customers and trainings for the employees, for you. Here, the EPLM can look at over 20 years of experience. Felix Henniges works as a technical consultant for additive manufacturing at the EPLM AG and supports companies to improve their product development along the PLM process using the features and opportunities offered by additive manufacturing. And today I welcome Felix here on stage. Hello, Felix.
Thank you, Thomas, for the introduction, and welcome all of the presentation here at the formnext Connect 2020. In the next 15 minutes, I would like to show you how you can use the opportunities offered by additive manufacturing successfully, and how we at the EPLM can support you in doing that. Additive manufacturing can change the nature of product development through its design freedom and opportunities. In the past, we had to think about the possibilities offered by manufacturing technology and design on this basis. Nowadays, we are able to develop our design almost freely and manufacture products that we never have dared to dream of before. So far, we have always looked at individual components of a product. But in order to unleash the power of additive manufacturing, we must look at the product as a whole and include it in the development process. So let's take a closer look at the development process, and especially at the area where the greatest impact on cost definition is. This is at the beginning of the product development. Here, the greatest possible savings, optimization potentials for the entire process. That means at this point, we must manage to reduce the later error rate as much as possible. So if we can detect errors in the design much earlier, it saves a lot of time and money in the product development. You all know it from your own experience. The later an error is detected, the more expensive it is to correct. The costs here increase by a factor of about 10 at each step in the development process. And that is the key to cost optimization at the beginning of the product development process. And I would like to show you how the additive manufacturing can help us to get right at the first attempt. So what might an approach look like that opens up this potential? In order to address our attempt to get the product right at the first attempt and reduce time and costs in product development, we use an agile approach. So multiple iterations in the early phase of a product development gives us the opportunity to create the right product according to its requirements. And additive manufacturing fits perfectly in such an agile process. Because additive manufacturing gives us the possibility to validate our products and components right from the CAD system as a real product. Through it, we have the possibility to have the design review done parallel to the engineering work. And that means designer can check and adjust the design at any time in the process. Up to now, this development approach has failed because the designer had to use a modular system of different software solutions. Through this very agile and iterative approach, with the interplay of do, check and adapt, we move from the previous approach we design for manufacturing to our new approach, we're manufacturing for design. This is a paradigm shift in development process. And of course, this requires a new type of designer. And after all, the possibilities of additive manufacturing must be taken into account from the very beginning of the design and development process. Today's products have higher requirements. We all know it. They should be lighter, stronger, and cheaper. This is very challenging the designer. And to manage these challenges, the actual design process must be rethought. So the manufacturing process of additive manufacturing offers great design freedom and possibilities. These include, for example, topology optimization. We can create bionic designs or lightweight construction using lattice structure. So you need an integrated tool chain that supports the designer in his work. But only if the designer are open-minded to these new approaches, additive manufacturing can truly change the product development process significantly. And I would like to show you an example of this. Let's take a closer look at the result by thinking out of the box and openly exploring the possibility of new technologies. Injection molding tools are very good examples. By using additive manufacturing, we can produce a tool that has a significantly higher performance thanks to the optimized near-surface tempering, which could not be produced in this way without additive manufacturing. And we have here 5 big benefits of this. We have higher cooling capacities. We get better quality of our components. We shorten our cycle times and reduce the scrap rate. And the best thing, we increase our output quantity. So now we'll have a look in the whole development process and how it looks like in the integrated tool NX. Here we start with a collection of data and parameters. We said at the beginning that the key to success is not only to see the individual components, but how they relate to the entire machine. We look at the movements, measure the forces acting, and look at the movement ready that are necessary. And after evaluating the analysis, we set the necessary parameters for the further construction. The second step is about generative design. We create a first design draft on the basis of the recorded data using the topology optimization integrated in NX. Here we define the design space, in the video shown in pink, the bodies and cutouts as well as the forces affecting them, and the system calculates a design proposal from this. And at the end, we get an evaluation and presentation of the maximum stress and maximum displacement with color legend and calculated values. And this generatively created design now forms the basis for our further mechanical construction. Now we take this generated design draft and process it further using the convergent modeling technology. And also the realized shape module directly in NX. The convergent modeling technology gives us the possibility to complete and combine the facet data with the precise BREP data. This means that we can adapt and complete the topology according to our design ideas and fully use the maximum design freedom. And thanks to this easy-to-use topology optimization, which is integrated into the CAD module, we can create a design that meets our requirements and is open for changes without a great time investment. Now we have adapted our model and we check if our part will meet the requirements. For this purpose, we have integrated the whole range of simulation functionality of SimCenter 3D in NX. So we hand over our model and put a mesh over it. So we enter the movements and forces to be measured and then simulate the effects on the component. Using a color scale on the component, then we can see where the weak points are and which we may need to adapt and optimize. In this way, we can test the component extensively before the actual production without doing expensive, destructive test measures. So this saves time and cost in development and leads us to the goal of our one first attempt. Now we came from the area of product design to the product preparation. Another very important component of the development process that has to be considered from the beginning, and this is actually the manufacturing process. Thanks to the complete bidirectional associativity in NX through the universal data format, we can include the part of the manufacturing validation from the beginning in the development and always check if our design draft is to be manufactured as intended. And depending on the manufacturing process, we check overhangs, wall thickness, ready or enclosed voids for the manufacturability. And this enables the construction and design development department to work even more closely with the manufacturing preparation department. And this is only possible thanks to the integrated software solution of NX and the agile and iterative development loops, which can save a lot of time and money. Once the final design and manufacturing have been validated, the component can be manufactured. The production is also controlled in 3D printing directly from NX. The support structures can be created manually or automatically, and then they can freely adapt it. As soon as the component is ready for printing, it is transferred to the relevant machine and printed. Because of the integrated toolchain of NX, we can also use all the CAM function and machine simulations for additive manufacturing. For example, for the post-processing of our component, you can prepare the removal, for example, of support structures in metal printing by a milling machine from the very beginning and test it by pre-simulation and integrate it into the overall process. Also, the separation from the printed plate via EDM is also possible and very easy to program. Here you see now, very good, the whole integrated process in NX with all the different steps you need in your product development in one software solution. At the beginning, I promised you to show you how you can use this opportunity offered by additive manufacturing successfully. So I would like to offer the following advices. Change your product development to an agile and iterative process by leveraging your open-minded designers. And use an integrated design software solution like NX to support your designers in this new holistic process. Save time and money by opening up the potential of additive manufacturing in the design process. And if you implemented these points in your PLM process, you can market, for example, your products faster by getting your products right at the first attempt and secure the important competitive advantages. And we at the EPLM support you in optimizing the PLM cycle from the first idea to production and recycling by using the opportunities offered by additive manufacturing, so that you can secure precisely those competitive advantages that are more important than ever in the current situation. So let us design your future together, and I thank you for your attention.
Felix, thank you for the impressive presentation today. I learned that EPLM has a deep knowledge in the complete additive manufacturing value chain, and that you can consult customers and so on. One question, could they also buy the software licenses directly from EPLM?
Yeah, that's possible. This is one of our 4 areas we support. Also the software, we implemented it, and we have also a corresponding support service for the software from NX.
Okay, this means all out of one hand from EPLM. You can work as customer together with EPLM to get the complete chain from support, consulting, implementation up to buying the licenses, all from one hand. Thank you very much for your presentation, and thank you for your attention.
Thank you.